Today's video here is a nice problem regarding arithmetic and number theory. Here is the following setup. Find all a, b, and c as non-negative integers. Satisfy this following equation. Okay. So we have the inverse of a plus the inverse of the sum of a plus b plus the inverse of this a plus b plus c equals 1. Okay. So our goal, we are going to determine all these values of a, b, and c as integers. Okay. Now let's go ahead and jump into this one. We know a 1 over a plus b plus c is inferior or equal to 1 over a plus b and is inferior or equal to 1 over a. Okay, we need to keep the inequality with equal sign since we have these values are non-negative integers. By summing these three terms, this one I will have 1 over a plus b plus c plus 1 over a plus b plus 1 over a is always inferior equal to 3 times over a. Okay, because the maximum of this, because the maximum values of each one is 1 over a, so we are going to sum of them is always inferior equal to 3 over a. Okay, so the whole of this bunch of these terms equals number 1. Okay, so we get 1 is inferior equal to 3 over a. This one implies a must be inferior equal to 3. Finally, a must be in this set 1, 2, 3. You might say, why a not equal to 0? Because we have a in denominator. We cannot put a with 0 in denominator. Okay, so now let's go through each one. Let's take the value of a equals 1. A equals 1. Plug in number 1 in each term here. I get here 1. I get 1 over 1 plus 1 over 1 plus b plus 1 over 1 plus b plus c, which equals 1. Okay, it's clearly 1 will be cancelled out from both sides. I will be left with this sum equals 0. Okay, which is impossible. Okay, you cannot have 0 here. So a equals 1 is not a solution. Let's move on to the next case. When you have a equals 2. So I'm going to do the same thing. Plug in a with number 2 here. I get 1 over 2 plus 1 over 2 plus b plus 1 over 2 plus b plus c equals 1. Okay, this one equals half plus half. So I'm going to cancel a half from both sides. I will be left with these two terms equals half. Okay, I'm going to do the same argument that I have previously here. So I get here, this one is smaller than this one. I get 1 over 2 plus b plus c is inferior equal to 1 over 2 plus b. So by summing these two terms, I get 1 over 2 plus b plus c plus the inverse of 2 plus b, which is inferior equal to 2 times over 2 plus b. We know the sum of these two terms. We know the sum of these two terms equals half. Okay, we get half is inferior to 2 over 2 plus b. I'm going to multiply this. I'm going to multiply side by side. I will be left with 2 plus b is inferior to 4. So 4 it's clearly equals 2 plus 2. Then cancelling out number 2 from both sides, I will be left with b is inferior to 2. So b is inferior to 2. So which means b belongs to this set 0, 1, and 2. Okay, 0 in this case is possible because we don't have any restriction points here. Okay, it's not like this one. Okay, because we have b is added to another integer, which means it's okay to be in denominator. Okay, remember here we're still working on this case, a equals 2. For b equal to 0, I get here half plus half 1 over 2 plus c. which equals number 1. So if I'm adding this to half, I get number 1, then cancel out number 1 from both sides. I will be left with this term, which is 1 over 2 plus c equals 0. This is it. Clearly it's impossible to have this one is 0, which means 0 will be rolled out of this possibility. Okay, let's check if b equals 1. Okay, consider a equals 2 as well. Okay, so I get here half plus this number 1 plus half this number 1 plus number 2, which is 1 over 3, plus 2 plus this number 1 of b, which is 3, plus c, which equals 1. Okay, if you add these two terms, over 3 is giving us 5 over 6. Moving over this 5 over 6 to the right, I get the following. I get 1 over 3 plus c equals 1 minus 5 over 6, which equals 1 over 6. Okay, consequently I get 3 plus c equals 6. In the other word, c equals 3. Okay, now we get the value of c equals 3, and then we get all the values e equals 2 and b equals 1 and c equals 3, which is a solution for this equation. So we get e equals 2 with b equals 1 and c equals 3. So we get the first solution. Now let's move on to the next value of b, which is the last value, b equals 2, to find another solution. So now let's move on to the next value, b equals 2. b equals 2, I'm going to replace a and b with number 2 in this original equation. So I got half plus 1 over 2 plus 2, which is 4, plus which is 4, plus c, which equals number 1. Okay, so adding this one on this one, I get 3 over 4. Then moving over this 3 over 4 to the right, I get here 1 over plus c equals 1 minus 3 over 4, which equals quarter. Okay, thus we get 4 plus c equals 4. In the other words, I get c equals 0. So c equals 0, which means I have another solution. I have e equals 2 with b equals 2 with c equals 0. Now we have done with the b. We are going to work on the last case when we have b, when we have e equals 3. Okay, I'm going to work on the value of a, which equals 3. So I will have the same job that I have before, replacing a with number 3. I get third here plus 1 over 3 plus b plus 1 over 3 plus b plus c equals 1. Okay, it's clearly I'm going to move over this third to the right. So I get here this one, it will be changed to 1 minus 1 over 3, which equals 2 over 3. Okay, by using the same argument I have previously, so I get this term smaller than this term. 1 over 3 plus b plus c is inferior equal to 1 over 3 plus b. I'm going to sum these two terms together. I get here 1 over 3 plus b plus c plus 1 over 3 plus b. This sum equals 2 over 3, which I have here. Okay, which is inferior equal to 2 times over 3 plus b. Okay, so which means I will have 2 over 3 is inferior to 2 over 3 plus b. Cancelling out number 2 from both sides, I will be left with, then taking the inverse of this one, I get here 3 plus b is inferior to 3. Okay, now 3 will be cancelled out from both sides. I will be left with b is inferior to 0. So b is inferior to 0. It has no choice except if b equals 0. Okay, I'm going to take the advantage of this value of b and insert it back into the original setup. Okay, considering a equals 3 as well. So I get here 1 over 3 plus 1 over 3 of course b will be replaced with 0 here, plus 1 over 3 plus c, which equals 1. Okay, so 1 over 3 plus 1 over 3, it's clearly is giving us 2 over 3. Moving over this term to the right, I will be left with 1 over 3 plus c equals 1 minus 2 over 3. Okay, so if you calculate this one, is giving us 1 over 3. So taking the reciprocal for this one, I get 3 plus c equals 3. Cancelling out 3 from both sides, it's clearly is giving us c equals 0. Okay, back again, we get both values are equal to 0. b equals 0 and c equals 0, but e equals 3. So I get the final solution. I get a equals 3 and b equals 0 with c equals 0. Okay, now we have done with this problem with these 3 solutions. By the way, don't forget to hit the subscribe button and support our channel by like and comments. So thank you for watching. I will see you next video. Bye.